Okay, so let's take a simple example. Let's say we drop a ball from a certain height. And this is what they have in, let's erase that. Let me just put G up here. So suppose we drop a ball from a tower, and they have the Leaning Tower of Pisa to make sense. Why else would you drop it from any other location? So let's draw a picture of the Leaning Tower. And it's really leaning now. It's hundreds of years from now. And we're standing on it and we drop a ball. Right? So here, what is our 0 point here? And then the ground is down here. What do we, and then they ask, how far has it, will it have fallen after a time? So what is x1? X2 and X3. And we can ignore the air resistance. So what are these positions? And we'll label this as X1, X2, and X3, right? So what should we use as our 0? Should we use this as our 0? How should we set up our coordinate system here? What's convenient? Which way is positive and which way is negative? So we're just asking about the distance that the ball travels after a certain amount of time. Where is a convenient 0 for us? Is it the ground or there's two spots, right? The ground or here. That's where your eyes usually go to.
Where the ball's being dropped from?
Yeah, from where the ball's being dropped from. Yes, it's from where the ball is being dropped from. Not only that, we'll conveniently call what you normally think of as down, or what we normally think as negative, we'll call that positive y. Right? So anything that's along this direction, the acceleration per se, or the ball moving, will make that positive. And because we just care about the distance that it travels. You know, this is x1, and then over here a time later, and then over here another time later, right? We just care about this distance. And this is t is equal to 1, t is equal to 2, and t is equal to 3. Right? So all we care about is the distance from where you drop it to. Right? So what's the initial, so we'll take this as y is 0, or I labeled it as x. Let me change the labels here. Well, so normally we call the vertical axis from now on y, and then we'll call the horizontal x. Stick with it. Okay. So instead of calling these x's, we're calling them y's. Simple. So, and we have this equation. So y initially is y0. What is the speed of the ball at 0? What is what is V0? Right at the instant we drop it, it's 0, right? Because there was no time for it to accelerate. So V0 is 0, right? So what equation we want to use? We want to use the position function. Instead of calling it x, we call it y. Y0 plus V0t is 1/2 a 0, right? We know y0. We know. So let's see what unknowns and unknowns we have, right? We know y0. We set it ourselves. We know V0, we dropped it, so we started from rest. That's 0. And A, the acceleration, which in this problem is G, of course, right? So we only have one unknown, right? Or we should say, and then we're given the time that we want to calculate the distance. So we know T. It's just calculated at a certain time. So we only have one unknown, right? So we end up with this formula, right? So then at y1, now let's plug it in. At y1, it's equal, this is just 1, so it's equal to, it just moves 1/2 g. y2, this is a square, so it moves 2g. And then y3 moves 9/2g. I'll put it in. .5 G. So if you compare it going from 0 to 1, it only travels 1/2 of G. But then going to 2 seconds, it travels. It ends up at 2G, which is 4 times as far as this, right? And it was the same increment, right? We're going from 0 to 1, and then from 1 to 2, right? That's the acceleration, right? The velocity changes, so it travels 4 times as much, and that's because of this of the square, right? So every time you double the elapsed time, it will travel 4 times as much, right? If you quadruple it, it will travel 16 times as far, roughly. And then for 3 seconds, we're only traveling. It's elapsed only 1 second, so it travels instead of 2, it's 2.5, right? It travels 2.5 times longer than at 2. All right, and this is that exponential function.
2.25 faster.
Yes, 2.25? Huh?
Yeah.
9 divided. Oh, I'm not talking about fast. I'm talking about the distance that it travels.
Oh, okay.
So this would be 9/4. So this is 4 point. So at 3 seconds, it travels 4.5 G down, right? And that's going from 1 to 2, right? It travels 1. Okay, sorry. Let me write this out. My word. So let's say 1. Let's say the distance it travels from 1 to 2. And this ends up being 1.5 G. Then when it travels from 2 to 3, it travels 2.5, right? So it travels 2/3 more, we should say, roughly. I'm just estimating off the top of my head. All right. And then from from 0 to 1, it's only traveling 0.5. So from 0 to 1, it's only going 1.5. Right? So for each second, it's gaining an extra. It's going an extra 1G further, right? So, and that's the skirt, So if we draw it, it'll look like that, right? As it's falling. And that's a free fall. And we'll be doing more problems like this. Let's end it here. And then I'll finish 2-7 on Tuesday. I'll post the homework and everything. I'll make it due Thursday. I'll finish 2-7 and then 2, 8, and 9. Work on it in the meantime. If you want to read at home, the rest of the chapter at home, look at example 2.16 and 2.19, and we'll cover two. So there's some optional sections in the book, 2.8 and then 2.9. I will go over it because I think those ideas are important, especially if you're a science major. I won't cover it too in depth, but it's just integral calculus. So they just go over the integrals, and then 2.9 they go over how to approximate integrals. So I'll go over that. I won't go as in depth as the other chapters, but I think it's important. So yeah, a homework for chapter 2 is due Wednesday. Work on it beforehand, because the chapter 3 homework will be due Friday. We have to try to keep to the schedule as much as possible. So, so definitely work on it at home, and you should be able to do most of the problems. So, any questions? Chapter 1 is due Friday at noon. You want me to extend the deadline for chapter 1? Do you want me to push it back for Saturday or Sunday? Yeah, some people didn't know how to get to the lectures and stuff, and
yeah, that would be good.
yeah. So why don't we do Saturday? Okay, have it do Saturday. Yes, the first lecture is up on YouTube already. You guys should be able to get the links on the Blackboard. And I'll post this lecture by tomorrow. Okay? Anything else, guys? Yep, you too. Take care, guys. Good luck.
Professor, about the 14-day trial you said,
Yes.
how do I get to use that?
If somebody could help them out, I don't know. I haven't used the website.
Because when
I
I
can
go
log on and see. Hold on. So I go to register. Okay, if you're on the website, then the instructor's course ID. Okay, register now. And then type in the course. Let me copy it over. What was the code that I put in? ProShare.
ProShare 120 2020.
Okay. And I put it in. I could share my screen actually if you want. Okay. So I started over here. Well, I clicked the student register thing down here. And then, okay, register. And then I typed in this. I don't have,
You want me to share my screen?
yeah, you share your screen. I'll make you, share your screen. Do you have permission or I have to?
No.
Okay. Okay.
Here, can you guys see?
Yep.
Okay, so this is the options it's showing me.
Okay. Go to this, click that.
Click which one?
The, hold on. I'm gonna, can you give me control? Are you okay with that or? Click
Yeah,
this.
sure.
Okay. Let me know when I have it. Okay. Let's see. Just type in, you know what, why don't we do this privately? Okay?
Okay.